Students, good morning all of you. Can you hear me properly? If you can hear me properly, just give me a response. Right. So just send me some small text. Right. Okay. Okay, students. Thank you very much for your response. Okay. Right. Now we can start today's lecture. Right. So before that, I just want to share the screen with you. Right. Now I have shared the screen with you, students. I need another confirmation from your side. Please tell me, can you see the shared screen? If it is clearly visible, right, okay, right, okay, good. Okay, I got your response. Thank you, students. Right. Now we can start today's content. Actually, today we are going to start lecture 11. This is actually some turning point in programming. Why I am telling like that? Because this is some sort of a very important section in programming. This one is called recursion, right? Recursion. This is some way, right? Some efficient way of writing programming, right? So all of us now we can write programs. We have learned different methods, but today we are learning a very special method called recursion to save our time and effort. Not only our time and effort, our computer's time and also computer's effort. Right. So now I am going to describe that. First of all, we'll go for small theoretical part. Here. You have learned programming in Python in detail. Right? Why do we develop programs? Now you know the answers for this. To solve problems. Writing programs is simply just part of the problem solving. Yes, we know that if we have a problem, we need to find a solution. By using a program, we are developing a solution. Right? Here, problem solving is the hard part. Right? Now we know that it's something difficult, the problem solving part. Here, in problem solving, we have learned very early, we have learned there are some steps of writing a solution. It means developing a solution. First of all, we just want to define the problem. Defining the problem means here, forget minor, not so important details and focus on the important aspects of the problem. First of all, we just want to get some clear idea about the problem. Right? We don't care about the minor things. Always we have to focus what is important inside this problem. Right? This defining means we already learned that we need to get some clear idea about the problem. Then we are developing an algorithm. Right? So we did those things. What is developing an algorithm? Identify common solutions that we can reapply. Here. Before, it means when we were starting this language, I already explained about these things, but today I am explaining something different. What is that? Here, identify common solutions that we can reapply. On that day, I told you, right? Think about a solution, prepare a solution, then we are writing the algorithm according to that, right? So, initially we identify the problem, then we are thinking about what type of inputs we have, what type of output we need to have in future. Then, according to that, how to do the solution. Then we are writing the algorithm according to our planned solution. But today, here, the new word comes, right? We are preparing a solution, but here, the common solutions that we can reapply, right? In the initial part, students, we didn't do anything called reapply. Reapply means what? නැවත apply කරනවාට. අපි එකපාරක් apply කරනවාට කියන apply. Reapply again තව පාරක් apply කරනවා. So just as an example, in real world, if you apply for a job vacancy, if you are applying again for the same job vacancy, what we call reapply. Right? Today we are going according to that concept. Here, use existing approaches and techniques. Use existing approaches and techniques, right? Not new ones. Right? Existing means what we have already. දැනට පවතින දේවල්. පවතින approaches, පවතින techniques, existing. එතකොට මේවම තමයි use කරන්නේ. We are using again and again. Then finally we are implementing the solution. Right? So now what is this? අපිට අපි සතුව මේ මොහොතේ තියෙන concept එකක්ම අපි නැවත භාවිතා කරනවා. Right? That is recursion. Recursion is a problem solving method where the solution depends on solutions to smaller versions of the same problem. Right? Now we know that in real world also, if we faced for a very huge problem, if we face very huge problem, it's very difficult to solve. Right? Very difficult to solve. Right? But if we face to a small problem, it's very easy to solve. Right? For all of us, this behavior is very common. Right? ලොකු ප්‍රශ්නයක් ආවොත් විසඳන්න අමාරුයි, පොඩි ප්‍රශ්නයක් ආවොත් සරලව විසඳ ගන්න පුළුවන්. In programming also the same. If we have a bigger problem, giving a solution for a bigger problem is very difficult. But if it is a small problem, just like if we need to get the total of two numbers, very easy. Right? But there is a method of solving this type of complex problems. We can divide, right? We can simplify the complex problem into the smaller versions. Right? Round by round, we can simplify it into very smaller versions. Right? Until we reach some level. Right? Until we reach the basic level. Once we came to the basic level, so it's very easy to solve. Right? So first of all, we are going down, just like simplifying to the basic level, one by one, stepwise, until we reach the basic level. Then, once we reach the basic level, we are solving the basic level, then go one step upwards, then solve that level, then again one step upward, solve that level. Likewise, we are going upwards until we are getting the solution for the huge problem, right? Here, how to do this? Now we know there is a method of doing this. Here, function that calls itself directly or indirectly to solve a smaller version of the task is recursive. Here in this concept, students, we are calling the same function again and again. But there is a different thing. What is that? We are calling the same function, but the parameters inside the function is different. We are calling the same function. It means the behavior is the same, but the parameters we are giving into the function is different, right? Always when we are calling the function in the first round, the parameter is little bit complex. In the next round, the parameters are simpler than the first round, right? Likewise, we are giving parameters, right, simpler when we compare with the previous round. Here, recursion occurs until a final call which does not require further recursion. I told you that this same function is calling again and again happens until we reach the basic level, right? Once we came to the basic level, we are not calling the function again, right? And the other thing, students, we need to apply some terminating conditions. It's very important. Otherwise, if we forgot to apply terminating conditions, what happens? We are calling the function again and again. There is no limit, right? There is no stopping point. We are calling again and again and again. It goes to, right, infinity, right? Infinity means no limitation. So at that time, if we forgot to put terminate conditions, our computer's memory, then hard disk storage, and the memory and processing power, the processing power, memory and storage, all the three things are wasting, right? Because there is no stopping point. Calling again and again, the same function calling again and again, right? Okay, now I think you have some theoretical background about this, right? Here, now I'm going to explain, right, how we are going to implement this. Here, some problems have natural recursive structure. First, take some example, right? What is this? This is called factorial. In mathematics, all of us, we have learned about factorial. I'm going to Sinhalen කියනවා ක්‍රමාරෝපිතය, right? So what is this factorial? Factorial කියන එකේ meaning එක මොකක්ද? Here, now I'm going to give you some example. Factorial. Here, factorial. ක්‍රමාරෝපිතය. If someone asks what is the factorial of 5, so how to write factorial of 5? 5 with exclamation mark. This is the symbol, the standard symbol used for factorial in mathematics. Actually, what is factorial 5? Right, what is factorial 5? 5 means, factorial 5 means, students, 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, right? Then here what is the next part? Right? 5 starting from 5, then multiply by 4, multiply by 3, multiply by 2, multiply by 1, like this. Here. This is the standard notation for factorial n. N multiplied by n minus 1, multiplied by n minus 2. Likewise, we can continue up to 1. But in this case, we need a stopping point. What is the stopping point here? We know that the factorial 0 factorial is 1. This is very important for us. Right? This is very important. Factorial 0 is 1. Right. Now, here. This is, we can see that this is recursive. How we can say this is recursive? Right? අපි කොහොමද මේක recursive කියලා කියන්නේ? Here, there is a way of saying recursive. Right? The way is, I'm sorry, here. Why we are calling this one as recursive? Think about this. Now, factorial 5 means 5 multiplied by 4 multiplied by 3 multiplied by 2 and multiplied by 1. So what is this? This is factorial 4. This is factorial 4. Right? Then if we write factorial 4 like this, 4 multiplied by 3 multiplied by 2 multiplied by 1, then what is this part? This is factorial 3. Here. Now you can see there is a recursive pattern. Right? Here I am going for a different type of diagram. Think about like this. I am going to put some line separation here. If I put factorial 5, factorial 5 means, you know that 5 multiplied by, here we got 5 multiplied by the remaining part is factorial 4. Right? Here 5 multiplied by factorial 4. Then what is factorial 4? 4 multiplied by factorial 3. Right? Likewise, we can continue. What is factorial 3? 3 means 3 multiplied by factorial 2. Right? Now you can see the recursive behavior here. Right? There is a recursive behavior. Right? Now we can continue this one up to some basic level. We can continue this one up to a basic level. Here I'll show you this one. Here, this is the behavior. Until we reach the basic level. So what is this basic level? The basic level means this is the basic level. If the value which is equal to 0, then we know that it means factorial 0 is equal to 1. This is the basic level. Right? Here. In the very next level, this one I can write it as 2 multiplied by factorial 1, then 1 multiplied by factorial 0. Then we know that factorial 0, this one, factorial 0, this part, we already know that this is the basic level. Factorial 0 means 1. factorial 0 means 1. Here. This is the recursion part. This is little bit complex. Finding factorial 5 is complex. Then we are going for a smaller versions. Here 5 multiplied by factorial 4. Right? Then again we are going for a smaller version. 4 multiplied by factorial 3. Again go for a smaller version. 3 multiplied by factorial 2. Again smaller version. 2 multiplied by factorial 1. Again smaller version. 1 multiplied by factorial 0. So from here onwards, no smaller version is available because this is the basic level. Once we reach the basic level, we have to stop. Right? We have to stop means this is not the end. Right? So what we are stopping, we are not calling the same function again and again. We are stopping that part. Now we know factorial 0 means 1. Now the answer is 1. Then we are going back. Now we are going back. So going back means 1 multiplied by 1. It's very easy to solve because this is very basic. 1 multiplied by 1. Then 1 multiplied by 1, the answer is 1. So with the answer, we are coming to the next level, 1. Then we know the answer for this. Factorial 1 is 1. How we got that? 1 multiplied by factorial 0. So factorial 0 means 1. We already know that. Then 1 multiplied by 1 is again 1. The answer for this level is 1. Now we are doing what? Here, now we are in this level. 2 multiplied by factorial 1 means now we know that the answer is 1. 2 multiplied by 1. With the answer we are coming to this level. The answer is 2. Then we are in this level. 3 multiplied by factorial 2. Now we found the answer for factorial 2. It's 2. 3 multiplied by 2. The answer is 6. With the answer we are coming to this level. 6. Then 4 multiplied by factorial 3. We know the answer for factorial 3. It's 6. 4 multiplied by 6. It's 24. So with the answer we are coming to this level. Then 5 multiplied by factorial 4. Right, 5 multiplied by factorial 4. We know the answer for factorial 4. We already found it's 24. 24 multiplied by 5. 24 multiplied by 5. So it's 120. So we are coming with that answer. Right. So finally we got the answer for factorial 5. Right. But our effort is very less. Right. So normally if we want to find the factorial of 5, we have to do this. We need to multiply 5, multiply by 4, multiply by 3, multiply by 2, multiply by 1. This is very difficult. But this process is very simple. Right? We are coming to the basic level. The multiplications are not much complex. Here, 1 multiplied by 1, 2 multiplied by 1, 3 multiplied by 2, right? Then 4 multiplied by 6. Always we have to multiply only 2 numbers. It's very basic. But finally, we are getting the answer for the complex problem. Now, I have explained this one only for factorial 5. What about factorial 100 or something bigger? So you have to multiply 100 multiplied by 99 multiplied by 98 multiplied by 97 multiplied by 96. Likewise, you have to continue up to 1. It's very difficult. But using this method, you can very easily get the answer. So this is the concept of recursion, right? Now students, before going for further steps, I just want some confirmation from your side. Have you got this concept clearly, right? I'm explaining many more things in future slides, but anyway, up to this point, are you clear, students? I need that confirmation. What's your idea? All right, okay. Okay, students, perfect. Right, thanks for your response. Right, so what about the others? Right, only 2 students respond to me. I'm waiting for others also. Okay, one more student. Right, so I think 46. Right, it means without myself 45 students are participating for today's lecture. Right, okay. Okay, students. Right, thanks for your feedback. Now I'm going to explain about this thing, right? How to write a recursion program. How to write the recursion program. Here, the same thing I have explained into you by using the secondary camera. It's available here inside the slide also. Here, if you want to find n, factorial of n, it is n multiplied by n minus 1 factorial. N minus 1 factorial means n minus 1 multiplied by n minus 2 factorial. Likewise, you can continue up to the basic level once you found 1 multiplied by 0 factorial. Right? This is the terminating condition. Right? Terminating condition means we are not going to call the recursion just after that, once we reach the basic level. Then we are going upwards. Then just after that we are going upwards. We are multiplying the very basic numbers, then going upwards. Right? Few minutes ago I have explained that. Here, the same thing. The factorial 5. The same thing I already explained. So I have attached the same content into your slides also. Right. Now, let's move on to this. How to write the programming part of this factorial. Here, now I am going to partition the screen into 2 sections. Right. Then you can get the idea. Here. Now let's see. Right. First of all, we just want to prepare. Right. We just want to prepare the function. So how to write the function? The keyword is def. Def is for definition. Then you can use any name that you want. Any name means you can't use keywords. Other than keywords, any name you can use. Here, fact. In this case, fact indicates factorial. And to find a factorial, we have to give some number. Factorial of 5 or factorial of 10 or something like that. We have to give some number. So number means we have to mention some parameter like this. And colon. Then, as I told you before, we need a terminating condition. Terminating condition means, students, once we have reached to the basic level, we have to stop this. We have to stop recursion part. We know that the factorial, right? So we can give any number for this, but once we reach to the basic level, reach the basic level means factorial 0. Factorial 0 means our basic level. Once we reach to the basic level, we have to stop. To do that, what we are going to do, we have to prepare a condition. If num means the parameter. If parameter which is equal to 0, what we have to do is, then we have to return 1. We are returning 1 because the answer for factorial 0 is 1. Factorial 0 is 1. Here we have discussed about that. Right? That's why we got this. Once we reach the basic level, we are not going to calling the recursion anymore. We have to stop from here. But the value of factorial 0 is 1. The same thing we are implementing here. Right? If the number which is equal to 0, so we are returning 1. Right? Else means other than that. Other than that, we are returning what? Return num multiply by, we are calling the same function, fact, the same function we are calling, but less than one number. Right? Here num multiply by fact, the same function we are calling, but as I told you before, the parameter is different. Parameter is much simpler than the previous one. Here num minus 1. Right? Num minus 1. Now let's see. Right? So now we already created the function. This is the function part. Up to this point, the function is created. Then you know that function is just like assigning a task to some person. But if we need to do that task, we have to call that person and ask him to do that. Other than that, he is not doing that task. So how to ask this person to do this? How to ask? Here, inside print, we are calling this function with the value that we want. Just as an example, factorial 5, like this. Right. Now let's see what is happening. Inside the print, we are calling the function with the value that we want. What is the value that we want? It's 5. Now, this value, once we call this, it directly goes to here. Right? I'm sorry. It directly goes to here with the value of 5. Right. It directly goes to here with the value of 5. Now we are going inside, and if we are checking if number is equal to 0, no, not equal to 0. Then if it is not success, we are going for else. Else what? Num means, now we know that it's 5. Right? It's 5. Here, I'm writing it here. 5. Then multiply. What is this? We are calling the function fact num minus 1. Num minus 1 means, num means 5. 5 minus 1 means 4. Again we are calling the function with 4. Right. Here. Now what's the value? Value 4. Recursion. Again we are checking the number is equal to 0. No, the number is 4. Again we are coming to else. Then we are doing what? Here 4 multiply factorial num minus 1. Now the num is 4. 4 minus 1. Now it's 3. Again we are calling the function here like this. Again we are calling the function with 3. Again we are checking number which is equal to 0. Answer is no. Then we are coming to here else. Then 3 multiply by factorial num minus 1. Num means now it's 3. 3 minus 1 it's 2. Right? Again we are calling the same function with the value of 2. Now the value of 2. Then still it's not equal to 0. Again come to else. 2 multiply by factorial 2 minus 1 means 1. Now we are calling the same function again with a different value. Now the value is 1. Still not equal to 0. We are coming to else. Then 1 multiply by factorial n num minus 1. Num means 1. 1 minus 1 means 0. Now again we are calling the same function with a different value. Now the value is 0. Now this is 0. Now what happens? Now the num is equal to 0. So we are returning 1. Now this condition is true. We are returning 1. We are returning 1 means I am writing it in blue color, the return part. So this is the last call we had, this one. Through that line we are returning here. Through the same line we are returning to here. Now we got the answer for this. Answer is 1. Now this part is 1. Now you can see, students, we are inside the else. That's why we have this behavior. 1 multiplied by factorial 0. Now we got the answer for 1. Now 1 multiplied by 1. 1 multiplied by 1. Now answer is 1. Now we got the answer for this. Then we have to return. Return means here where we are going to return. We are going to return in this line. Here we already returned this one and the previous one. Here this one we have to return. Here, through this one I am coming. Here through the line I got a different one. Here through this line I am coming to here. I am coming to here, this level. Right, now we got the answer for this one, also 1. Then 2 multiplied by 1, it's 2. So we have to return this one. Here, this one. We already returned this red line and this red line, and we have to return the next one. Now it means this, right? This one. Here we have to return that one. Here, like this. We are coming to here. Then what's the answer? Answer for this one is 2. Then 3 multiplied by 2, 6. 6 is returning through this line. Right? So we are returning from here and we are coming to here. Then answer for this one is 6. Right. Then 4 multiplied by 6. 4 multiplied by 6 means 24. So we are returning this one. So I'm sorry, we are returning this one. This one and coming to here for this one. This is 24. Then 5 multiplied by 24, it's 120. Then we are returning the final call like this. Returning the final call and we are coming to here. So the answer for this is 120. So we are inside a print. Because of that we are printing 120 in our output. Right? So this is the behavior. Right? We are calling again and again and again until the basic level. Then once we found the answer for the basic level, we are returning from the last level. Last level, again we found the answer, again next level return. Likewise, we are returning all the levels until we get the first call. Once we return to the first call, we got the answer for the final, right, solution. Right? So this is the way of calling recursion, the recursion method. Right. Is it clear for you, students? I know that this is a little bit difficult, but you should understand the concept. So what is your idea? Is it clear for you? You got the point? Or if you are not clear, just tell me, I will explain it for you again. Right? What's your idea? If you are clear or still not, please tell me. I need your genuine answer. Because I know that this is a little bit complex. I just want to make sure that you got the correct understanding. Right? Right, okay. Right, perfectly clear, understood. Right, clear, right. Okay, well done, students. Well done. Right? Then, now you identify the concept. Identify the concept. So, what you can do, once you have identified the concept, then you can go for some exercise. Right? Here. I'm sorry. Now, there is a small activity. Define nth power of x recursively. Right? Write a Python function power of to recursively calculate the nth power of x. Right. Here, now what is this? I just want to explain a little bit more. Right. Here, what is this nth power? Nth power means, here I am taking a new paper. Here, nth power, 2 to the power n. Right? What is 2 to the power n? To understand this, we'll take some small example. 2 to the power 3. 2 to the power 3 means actually what? 2 multiplied by 2 multiplied by 2. We are multiplying 2 3 times. This is 2 to the power 3. Right. Now, here students, what is this? How we can apply recursive here? How to apply recursive? Here, now you can see this part. What is this? This is 2 to the power 2. Then 2 multiplied by 2 to the power 2. Right? Then if we write 2 to the power 2, what is 2 to the power 2? 2 multiplied by 2. Then what is this? 2 to the power 1. Then if we write 2 to the power 1, what is 2 to the power 1? 2 multiplied by 1. 2 multiplied by 1, what is this? This is 2 to the power 0. Right? So, now you can see in this one also you can create a recursive behavior. Right? You can create a recursive behavior. So what is that? Here, always, just as an example, we can write like this. Here, 2 to the power 3 means, here we can write 2 multiplied by 2 to the power 2. Then 2 to the power 2 means 2 multiplied by 2 to the power 1. Then 2 to the power 1 means 2 multiplied by 2 to the power 0. So this is the basic level. 2 to the power 0 means we should know it's 1. Any value, the power of 0 means 1. It's a mathematical thing. We already know. This is 1. If we know this is 1, 2 multiplied by 1 it's 2. Then this level answer is 2. Then 2 multiplied by 2, the answer is 4. We are coming with the answer here. Now we know the answer for this one is 4. Then 2 multiplied by 4, then the answer is 8. So 8 is the final answer. Right? Okay. Now this is the behavior. Right? Now what you should do? Right? Now there is a question. Now there is a question here. So what is this question? It's some sort of activity. Now I have explained the behavior. Right? What is the behavior? Write a Python function power of. They already given the name also. The function name is power of. What we should do to recursively calculate the nth power of x, to find xn, we should find xn. Xn means what here? If we say xn, xn means we can put any number for x, just as an example like 2. N means any power, any number for x, any power. But what's the behavior? The behavior is x multiplied by x. Then here n means the next round this becomes n minus 1. Then again x multiplied by x n minus 2. In next round x multiplied by x the power of n minus 3. Likewise this can be continue up to x multiply by x power of 0. X power of 0. So this is the basic level. For any number, the power is 0 means this one is our basic level. Is the basic level. And we know the answer for this one is 1. Right? For this one, the answer is 1. Then we can go upwards to get the solution for xn. Right. Now students, please tell me, have you understood the background, the required background that I have explained for you? Is it clear? To do this activity, I have explained the background. Right. Okay. Right. All of you got the understanding. Perfect. Right. Now students, what you should do, now you have to prepare a Python program to get this power of value. Right. So I will give you some time to try it by yourself. Right. So in this case, I am expecting from your side, you have to try this. Right? Sometimes it means most of the times you can success, but sometimes unfortunately if you are unable to prepare the function properly, that's fine, but it's better to try, right? So now I am giving you right, take 5 minutes of time, right? Then try to develop a function for this, right? Then just after the 5 minutes of time, then I am going to explain this function for you, right? Are you ready to start this activity? Are you okay, students? You are ready? Okay, right? You are ready. Now I am going to give you the time for that here. Right, students. Now this is your activity and also the background information, right? So better to take a screenshot of this one, right? All of you get a screenshot of this one. This is the question. This is the activity. Then just after taken the screenshot, then I will show you the secondary camera view, because inside that secondary camera view you have all the required background knowledge to do this, right? Okay, now I think all of you got the screenshot, right, students? Here, now this is the thing that you require to do this, right? Take the support of all the information which I have wrote inside this A4 sheet and develop your own program by using recursion, right? Okay, take your time. Right, students. How many of you are finished? Just give me a response. Right, if you are finished, just give me a small message. Then I can go for the discussion. What's your idea? Those who are finished, please tell me. Right, if you are still trying, students, please send me a message. Please indicate yourself as you are still trying. තාම කරගෙන යන අය try කරන අය මට message එකක් දාන්න. Right, okay. Right, so I'll give you some more time, right? Okay, take your time. Right, students, now how many of you are finished? Right, okay, one student respond to me, right, he's already done. Right, what about the others? I need to know about your status. What about the others? Right, perfect. Right, now we can go for the discussion, right? Okay, perfect. Now students, here, this is the activity and I am going to explain this. Right, now you can check your answer. It means what you have prepared. It means your program and this program, right? Here I am going to explain this program with you. Right, now I am going to partition the screen into two sections. Right, now, so what is this? We just want to find the power of n. It means we don't know, right, what is x, what is n. For any x, any n, right, the program should be work. Right, let's see. The program is def, the function name is already given by them, power of. Power of. Right, then there are two parameters. What are the two parameters? One is x, the base value, and the n is the power. Right. We need two parameters, the base value and the power. Then if n means the power, which is equal to 0, we know that for any value, the power of 0, 2 to the power 0 or 5 to the power 0, any value, the power of 0, we know the value is 1. That's why we are returning 1. All the other scenarios, it means all the other cases, n which is not equal to 0, what we are going to do, we are returning x multiplied by, we are calling the same function, power of, base value is same, but the power is less than 1. Initially it's n, we are calling n minus 1, like this. Here, now you can see this. Now I am going to try this program, right? Because we are going to call this function with some value here. Now this is the function part up to this point. This is the function. Now we are going to call this function. Other than that, this is not working. Here, how to call this function? Inside a print, I am calling this function power of, x value I am giving 2, then n value I am giving 3, like this. Right, now what I have, right, inserted here as parameters 2 and 3. 2 is the base value, 3 is the power, 2 to the power 3. Right, now once I have called this, what happens here? I am calling this function with two values. This is 2, this is 3. Now what happens? Now n value is 3, which is not equal to 0. The first time if condition is false, because of that we are coming for else. Then else what we are going to do, x means 2, right, 2 multiply by, here I am going to call power of here 2, n minus 1. N minus 1 means initially it's 3, now it's 2. Again we are calling the same function with two different values, 2 and 2. Right, now this is 2, so I am marking this one as 2 and 2. x2, n2. Still n is not equal to 0. Because of that, if condition is false, then again we are coming for else. So we are doing what? Then again 2 multiplied by power of, then 2, x value is same, n minus 1 means initially it's 2, now it's 1. Then again we are calling the same function with different parameters 2 and 1. 2 and 1. Right? Just a second, students. 2 and 1. Now n value is 1, not equal to 0. It means still if condition is false, when we are coming for else, here I am writing the same thing here because I have no space. 2 multiplied by power of 2, then 1 minus 1 is 0. Right, is 0. Then again we are calling the same function with 2 and 0. Now this is 2, this is 0. Now the n value is 0. If the n value is 0, this condition is true, we are returning 1. We are returning 1 means we are going through this line. Here, we are going through this line and comes to here. Now we know the value of this one is 1. Then 2 multiplied by 1, the answer is 2. We are inside else. So we have to return. 2 multiplied by 1 is 2. So we are returning through this line, the next line. We are returning like this. Then we are coming to this point. Now we know the answer for this one, this part. Right? It's 2. Right? This part is 2. This one. Then 2 multiplied by 2, it's 4. So we are returning through this line. Like this. And we are coming. We are coming to here. Right. Now we know the answer for this part. It's 4. It's 4. Now 2 multiplied by 4, it's 8. 8 means we are returning to the place where we call the function. It means here. Now we got this answer for this part is 8. Then we are printing in our output as 8. Because we called 2 to the power 3, then we got the answer as 8. Right? So this is the behavior. This is how this program is working. Right? Okay. Now please tell me, students, have you understood that? Right? It means I am asking from both of you. Both of you means those who have prepared your program perfectly well, and you can compare with my answer and give me a response. And there are some students, those who were unable to complete the program, but now I already explained. If you understood this, please tell me that, respond also. Right, sir, could you please explain how the return function works here. Right, very good. Good question. Here, return function means like this, students. Here, right. I think, yeah, I'm taking very small example to explain this. Here, the same program, def power of, then here x and n, if n which is equal to 0, return 1, else return, then x multiplied by power of x n minus 1. Right, let's see. I'm taking very simple example. Very simple example. We are calling from here print x means 2. I'm taking the power of 2. So here I'm taking 3 2. I just want to find 3 to the power of 2. It means 3 multiplied by 3. Answer is 9. Now let's apply for this one. Right. The initial call is this one. We are getting 3 and 2. Now this is 3, this is 2. Still n is not equal to 0. If condition is false, then we are going for else. Then we have a return. So we are calling x means 3 multiplied by power of 3. N minus 1 means this is 1. Is 2. 2 minus 1 means 1. Then again we are calling. With different values 3 and 1. Right here. We are inside a return, but we can't return because inside this we are calling the function again. Right? අපිට මෙතන return වෙන්න බෑ. මොකද return වෙන්න බැරි හේතුව අපි මේ statement එක ඇතුලේ ආයි call කරනවා function එක. ඒකින දැම්ම return වෙන්න බෑ. Right? අපි reverse වෙනකොට තමයි return වෙන්නේ. Return වෙන්නේ මේ value එකත් හොයාගෙන ඉවර වෙලා. Right? We are going to return with the value what we got in this statement. Right, then now this is 3 and 1. Still n is not equal to 0. Because of that, if condition is false. Again we are coming to else. Again we have to return statement. We are returning. But the thing is 3 multiplied by power of 3. Then here this is 1. 1 minus 1 is 0. Again we are calling the same function with two different values 3 and 0. Still we can't return because we are calling the same function again. Right? Now you can understand what is return. අපිට තාම එකපාරක්වත් return වෙන්න බැරි වුණා. මොකද ඒ statement එක ඇතුලේ ආයේ function එක call කරනවා. Right? එතකොට ඔයගොල්ලෝ මේ concept එක I'll give you some practical example. Just like there is a room. Once you open the door of that room, you can't return. The thing is, inside that room there is another door. You are opening that door also. Right? Then you are going for another room, but it's smaller than the previous room. In that room also you can't return because inside that room also there is another door. You have to open these doors again and again until you found a room without doors. අපි කාමරයක දොරක් අරගෙන ගියාම රිටර්න් වෙන්න බෑ. ඒක ඇතුලේ තව දොරක් තියෙනවනම්. ඒ දොරත් අරින්න ඕනේ. ඒ දොරත් අරලා අපි තව කාමරයකට යනවා. හැබැයි කලින් කාමරයට වැඩිය සයිස් එකකින් පොඩි. ඒ කාමරය ඇතුලේ තව දොරක් තියෙනවා නම් ඒ දොරත් අරගෙන ඇතුලට යන්න ඕනේ. රිටර්න් වෙන්න බෑ. රිටර්න් වෙන්න පුළුවන් වෙන්නේ යම්කිසි අවස්ථාවක අපි ඩෝ එකක් අරගෙන රූම් එකට ගියාම ඒ රූම් එකේ ඇතුලේ වෙන ඩෝස් නැත්තම් අන්න එතන ඉඳන් අපිට රිටර්න් වෙන්න පුළුවන්. right? එහෙනම් ඒ රූම්ස් ඒ ඩෝස් නැති රූම් එක මොකක්ද? අපේ බේසික් කන්ඩිෂන් එක. අපේ බේසික් කන්ඩිෂන් එකට ආවම එතනින් එහා ඕපන් කරන්න ඩෝස් නැහැ. එතන ඉඳන් අපිට රිටර්න් වෙන්න පුළුවන්. right? එතකොට අන්තිම රූම් එකට ගියාම ඒකේ ඩෝස් නැත්තම් අපිට පුළුවන් ඒ රූම් එකේ ඩෝ එක ක්ලෝස් කරගෙන එළියට එන්න. ඒක තමයි රිටර්න් කියන්නේ. ඊට පස්සේ ඒ එන්නෙත් අපි තව රූම් එකක් ඇතුළට. කලින් රූම් එක ඇතුළට. ඒ රූම් එකේ ඩෝ එක ක්ලෝස් කරගෙන ගියාම ඊළඟට අපි එන්නේ ඊළඟ රූම් එකට. අපි මුලින්ම එන්ටර් වෙච්ච රූම් එකට. ඒකේ ඩෝ එක ක්ලෝස් කරගෙන එළියට ගියාම තමයි අපි රිටර්න් එක කම්ප්ලීට් වෙන්නේ. right? The very a practical example in real life is room with a door. Once you open it, there is another door. Right? If you have some doors, you have to open it again and again until you found a room without doors. Then just after that you can came back. Came back means returning. Right? Here දැන් මෙතන අපි කෝල් කළේ 3.0යි. එතකොට දැන් n බිඳුව වෙලා ඉවරයි. ඔන්න දැන් අපිට රිටර්න් වෙන්න පුළුවන්. n බිඳුවයි. n බිඳුවයි කියන්නේ මෙතනින් එහා අපිට මේ රූම් එකේ වෙන ඩෝස් නැහැ. මොකද බිඳුව වෙලා ඉවරනේ. එතකොට අපෝ මෙතෙන්ට යන්න ඕනේ. මේකට ගියොත් තමයි තව ඩෝස් තියෙනවා කියන්නේ. right? එතකොට මේක රිටර්න් වෙනවා. රිටර්න් වෙනකොට මේක දැන් රිටර්න් වෙන්නේ 1 කියන වැලියු රිටර්න් වෙනවා. ඒ කියන්නේ මෙන්න මෙතන answer එක තමයි 1. answer for this part is 1. now අපිට පුළුවන් දැන් මේ දොරත් වහගෙන එළියට යන්න. මේ ඉන්නේ අපි රිටර්න් එකක් ඇතුලේ. 3 multiply by 1 answer is 3. අන්නේ මෙන්න මේ පාත් එක දිගේ එළියට එනවා කියන එක. ඒ දොරත් වහගෙන අපි එළියට එනවා. here එතකොට මේ කොටසේ ආන්සර් එකත් අපි දන්නවා දැන් 3. මේ දොරත් වහගෙන අපිට එළියට එන්න පුළුවන්. 3 multiply by 3 කියන්නේ 9. එතකොට ඊළඟ දොරත් වහගෙන අපි එළියට එනවා. ඊළඟ දොර කියන්නේ කෙලින්ම අපි ෆන්ක්ෂන් එක කෝල් කරපු තැන. එතකොට මෙතන 3 multiply by 3 9 තමයි මේකේ output එක. right? so here මම ලියලා තියෙනවා වැරදි. මේකට එන්න ඕනේ power of කියන නම. right? මේක හරි ගස්සන්න. print එක ඇතුලේ power of කියලා දාලා ඕනේ 32 දාන්න. එතකොට මේ return වෙන්නේ මේ value එකත් එක්ක. එතකොට මෙතන මේ කොටසේ value එක අපි දැන් දන්නවා. ඒක තමයි 9. එතකොට මේක screen එකේ ඔයගොල්ලන්ගේ print වෙනවා output එකේ. right? එතකොට return වෙනවා කියන්නේ අපි අවසානයේ දක්වාම ගිහිල්ලා තමයි රිටර්න් වෙන්න ගන්නෙ. තවත් ඩෝස් නැත්තම් ඒ රූම් එකේ දොර වහගෙන අපිට එළියට එන්න පුළුවන්. එතකන් අපිට එළියට එන්න බෑ. right? okay. දැන් මම මෙතන එක ලියන්නම්. power of 32. ඔය විදිහට තමයි අපි ෆන්ක්ෂන් එක කෝල් කරන්නේ. right? okay. The student who asked the question, are you clear, student? Is it okay for you? Then පැහැදිලිද return කියන දේ? What's your idea? Here since it says to return 1 when n equal 0. Does it mean to output 1? Yes. Right. It means output to 1. ඒ කියන්නේ n බිඳුව වෙන මොහොතේ ඒ කියන්නේ අපේ last point එක n බිඳුව වෙන මොහොතේ කියන්නේ last point එක basic level එක. එතෙන්දී return කරනවා 1 කියන්නේ ඒ level එකේ output එක එකයි. ඒක අරගෙන තමයි අපි මෙතෙන්ට එන්නේ. right? මේ last call එක. ඒක අරගෙන එන්නේ මෙතෙන්ට. ඒ කියන්නේ අපි call කරපු තැනට එන්නේ. call කරපු තැන එතකොට value එක එකයි. එතකොට ඒක multiply වෙන්න ඕනේ 3 ගෙන්. එතකොට 3 multiply 1 3 multiply by 1 answer එක 3. ඒකත් return වෙන්නේ. මේ returns නේ. අපි else ඇතුළේ ඉන්නේ. එතකොට ඒ return වෙන්නේ අපේ ඊළඟ call එක දිගේ. ඒ කියන්නේ අපි එන්නේ මෙතෙන්ට. එතකොට ඒ call කරපු කොටසේ answer එක 3. එතකොට ඒ answer එක ආයෙත් 3 ගෙන් multiply වෙනවා. 9. 9 කියන්නේ ඒකත් return එකක්. ඒක return වෙන්න ඕනේ අපි ඊළඟට call කරපු තැනින්. ඒ කියන්නේ main call එකේ. ඒ කියන්නේ මේ කොටසේ answer එක 9. ඒක print එක ඇතුළේ හින්දා තමයි අපි print කරන්නේ. right? Are you clear? Right, what about your status? Okay, it's my pleasure. Right, what about other students? Are you perfectly clear about this concept? Please tell me. Right, good. I'm waiting for others. Okay, okay. Right. Okay, students, well done. Now we can move for the next part. Then another example, right? This one is called Fibonacci numbers. Fibonacci, right? First of all, I just want to give some idea what is this Fibonacci. Right. Here, what is this Fibonacci? Fibonacci is a series of numbers. Here, just like this: 0, 1, 1, 2, 3, 5, 8, 13, 21, likewise. This is a Fibonacci series. මොකක්ද මේ Fibonacci series එකේ තියෙන විශේෂත්වය? Fibonacci series එකේ students මෙන්න මේ කොටස් දෙක අපි ගන්නේ basics හැටියට. basics. එතකොට බලන්න ඕගොල්ලෝ මෙතන වෙන දේ. මේ දෙකේ එකතුව තමයි ඊළඟ එකේ output එක. 0 plus 1 1. ඊගාවට මේ දෙකේ එකතුව තමයි ඊළඟ එකේ output එක වෙන්නේ. 1 plus 1 2. ආයිත් මේ දෙකේ එකතුව ඊළඟ output එක. 1 plus 2 3. ඊගාවට මේ දෙකේ එකතුව එනවා ඊළඟ output එකට. 2 plus 3 5. Here මේ දෙකේ එකතුව ආයිත් ඊළඟ output එක වෙනවා. 3 plus 5 8. ඊගාවට මේ දෙකේ එකතුව ඊළඟ output එක. 5 plus 8 13. මේ දෙකේ එකතුව 8 plus 13 තමයි 21 වෙන්නේ. right? ඔය විදිහට මේක මේ අතර ඕන තරම් දුර අපිට යන්න පුළුවන්. There is no limit. හරි. එතකොට Fibonacci. එතකොට මේ numbers මොනවද? මේ පළවෙනියටම තියෙන number එක. මේකට අපි කියනවා Fibonacci 0. මේක Fibonacci 1. මේක Fibonacci 2. Fibonacci 3. මේක Fibonacci 4. right? මේ තියෙන්නේ values. Fibonacci 5, Fibonacci 6, Fibonacci 7, Fibonacci 8 ඔය විදිහට යනවා. right? මේ sequence එක. කවුරු හරි Fibonacci 0 කියන්නේ මොකද්ද? 0. Fibonacci 1 කියන්නේ 1. Fibonacci 2 කියන්නේ 1. Fibonacci 3 කියන්නේ 2. Fibonacci 4 කියන්නේ 3. ඊගාවට Fibonacci 5 කියන්නේ 5. Fibonacci 6 කියන්නේ 8. Fibonacci 7 කියන්නේ 13. Fibonacci 8 කියන්නේ 21. Right? මේක series එකක්. එතකොට I'm sorry. මොකද්ද මේ Fibonacci series එකෙන් කියන්නේ? Right? Sorry. Right. Then මේක series එකක්. දැන් අපි මේ series එකේ කවුරු හරි කොතනක හරි අපෙන් ඇහුවොත් Fibonacci 7 කීයද? Fibonacci 6 කීයද කියලා අපිට එකපාරට කියන්න බෑ. එහෙමනම් අපි මේ order එක ඇඳලා බලලා ඕනේ කියන්නේ. හැබැයි ඒකෙත් මේ මුල් numbers ටිකෙන් එකක් ඇහුවොත් if some person asks the early numbers, then we can give the answer. But what about if someone asks what is Fibonacci 20, what is Fibonacci 30, what is Fibonacci 50? So it's very difficult to give the answer. එහෙනම් අපිට මේකෙත් පාවිච්චි කරන්න පුළුවන් අපේ recursive කියන option එක. Right. මේ තියෙන්නේ අපේ recursive එක පාවිච්චි කරලා අපි කරන program එක. Right. එතකොට ඕගලන්ට මෙතන බලා ගන්න පුළුවන් මම මේක explain කරන්නම්. මේ Fibonacci series එකට අපි කොහොමද recursion එක පාවිච්චි කරන්නේ? How we are going to use this method called recursion for Fibonacci series. Right. එතකොට මෙතන basic condition එකක් ගැන අපි කතා කළා. මම ඔයගලන්ට කිව්වා the basic condition. Basic condition එක 0 1 කියන දෙක. Right. There are two basic conditions 0 and 1. ඒ කියන්නේ එක හෝ එකට අඩු 1 or less than 1 are basics. 1 or less than 1. Here now you can see 1 or less than 1 are basics. At that time we are returning the same value. We are returning the same value. Right. Let's see. බලමු එක හරිද කියලා. හරි. බලන්න. කවුරු ආවෝ Fibonacci 0. Fibonacci 0 කියන්නේ ඒ value එකමයි. 0මයි. Fibonacci 1 කියන්නේ 1මයි. Right? Here Fibonacci 0 means 0. Fibonacci 1 means 1. No difference, no value difference. The same value. Right? Fibonacci 0, the answer is 0. Fibonacci 1, the answer is 1. That's why we are returning the same value. But just after that, it's completely different. Right? Here, this is the turning point. Just after that, completely different. Fibonacci 2 means 1. Fibonacci 3 means 2. Fibonacci 4 means 3. Fibonacci 5 means 5. Fibonacci 6 means 8. Likewise, different numbers. Right? Now you understood what is the concept here. Now we can prepare a program. This is our program. Now I am going to explain this program for you. Right? Okay, let's see. Now I just want to go for a new paper. Right. Sorry. Here. So we partition the screen into two sections. Here, def fib is the function name n. If we have to write the basic level, n is less than or equal to 1, we are returning the same value. Return n. Other than that, else, we are returning what? We are returning fib n minus 1 plus fib n minus 2. යම්කිසි වෙලාවක අපෙන් ඇහුවොත් Fibonacci n කියන අගය. If someone asks Fibonacci n, it is the value of two previous Fibonacci numbers. Right? අපි උදාහරණයක් ඇටියට Fibonacci 3 ගමු. Let's see if someone asks Fibonacci 3. What is Fibonacci 3? Fibonacci 3 එක හැදෙන්නේ කොහොමද? What is Fibonacci 3? It is the value of Fibonacci 1 plus Fibonacci 2. Fibonacci 1 plus Fibonacci 2, then you are getting the value for Fibonacci 3. Fibonacci 3 එක හැදෙන්නේ Fibonacci 1 එකේ value එකයි Fibonacci 2 එකේ value එකයි එකතු වෙන්නේ. That's why we put, if we are going to find Fibonacci n, how to get it? Fibonacci n minus 1 plus Fibonacci n minus 2. Right? So this is the way of doing that. Right. Then අපි පොඩි අගයක් අරගෙන මේක කරලා බලමු. Right. Now I am going to call this print. Inside print, here we have to maintain some space to write. Here, print. Inside print I am calling fib3. Now I am going to find Fibonacci 3. Right. Okay, then I am calling from here our function with the value of 3. Now the value of n is 3. It's not less than or equal to 1. It means if condition is false, we are coming for else. Right. Then return, I'm calling fib n minus 1. N minus 1 means 2. Right. Then what happens? Now we have two function calls. මෙතන function calls දෙකක් සිද්ධ වෙනවා. හැබැයි අපි මේක තමයි මුලින්ම call කරන්නේ. fib2. එහෙනම් මේකට යන්න කලින් අපි මේකට යන්න කලින් මෙතෙන්දී ආයෙත් call වෙනවා මොකක්ද මේ function එකම value එක 2 කියලා. value එක 2. right? තාම අපි මෙතෙන්ට ගියේ නැහැ. We are not going for this. මෙතරම call වෙනවා. fib2. 2 is also not less than or equal to 1. It means this if condition is false. Then we are coming for else. Again return, we are calling fib n minus 1 means now this is 2, fib 1. Right? Again we are calling. Again we are calling this. Right? Now here we are calling with 1. Right? If we put some numbers, this is the initial call, number 1. Then this is the second call, number 2. Then inside that we are calling again this number 3. Right? Is number 3. Now this is 1. Now this is true because the basic condition reached. N less than or equal to 1. Here n is 1. Then we are returning n. Returning n means same value. Then n කියන්නේ එකයිනේ. එහෙනම් return කරන්නේත් එකයි. එහෙනම් අපි අන්තිමටම call කරපු එක දිගේ return වෙනවා. මෙන්න අපි return වෙනවා 3 කියලා call කරපු එක දිගේම. return වෙලා මෙතෙන්ට එනවා. දැන් අපි දන්නවා මේකේ value එක 1. ඒකේ value එක 1. හැබැයි අපිට මෙතනින් දැන් මෙහෙමම return වෙන්න බෑ. We can't return now because we did only this part. We have another part just after that plus fib n minus 1 is 1. Why got n minus 1 is 1? Because 2 minus 1 is 1. 2 minus 1 is 1. Now 2 minus 2. Now this is 0. Here, now we got the answer for this one, but we can't return. We have to call this part also. Right? We have to call this part also. Then we are calling again the same function with the value 0. Right? Now, what is this? So, I am naming it this one as, right, this is the third one. The third one, part A is returned. This is 3A. 3A is returned. But we are calling in third round another one. This is 3B. A part and B part. A part is already finished, but we have to call 3B. Now n is 0. It's less than 1. It means this condition is true. We are returning n. We are returning with the same value. It means we are returning with 0. Here we are returning with 0. Now this part is 0. Now 1 plus 0. 1 plus 0 means 1. 1 means we are returning through this second step. We are returning through this second step. Here, like this. We are returning through this second step. Like this. Now we know the answer for this one. It's 1. Here 1 plus 0, it's 1. Now this is 1. But we can't return now. There is another part here. There is another part here. So this is 2. N minus 1 is 2. Why is that? Because we called 3 minus 1. 3 minus 1 it's 2. Now we have another part. 3 minus 2. It means fib 1. Now we have returned from second step means we have returned from 2A. But we have to call again like this. This one with the value. I'm sorry. So I just want to make it red. Sorry. I will erase this one and again draw with the red color pen. Right here. So we are calling this one again with the value of 1. So what is this round? Second round. Second round A is finished. So this is 2B. 2B. Right here I make it 2A. This is 2B. Now what? Now the value is 1. It's equal to 1. It means if condition is true, we are returning n. Same value. We are returning with 1. Here. This is how we are returning. Here. We are returning with the value of 1. Then we are getting this one as 1. Now 1 plus 1 it's 2. 1 plus 1 is 2. So we are returning to the main function call and we got this value as 2 because 1 plus 1. Now in our output we are getting the output as 2. Fibonacci 3, the output is 2. Shall we check? This is Fibonacci 3. What is the output? It's 2. The answer is correct. Right? This is how it's working. This little bit complex. Why is that? because inside the same statement we are calling the same function two times, right? Not single time. In previous examples we are calling only one time, but we are calling two times. That's why this program is a little bit complex than the previous one, right? Have you understood, students? What is your idea? Is it clear for you? What's your idea? I need to know about your status. If you have some questions, please ask. Other than that, I just want to know about your status. If you are clear, just tell me you are clear. If you have some matters, please ask. What's your idea? Right, okay, clear. Right, perfect. Right, okay, students. Well done. Perfect. Thanks for your response. Now, you already know about this. Right. Now, there is one more example that I need to explain for you. This is how we are going to reverse a string by using this concept. Reverse a string. Right. Here, I will explain that one also. Okay, now I am going to partition the screen into two sections. Right. Okay, first of all, I am going to write this program. Def, the name of the function is reverse, then str means our parameter, then if len str, you know the meaning of len function, less than or equal to 1, we are returning str, then else we are returning what? We are returning str minus 1 plus we are calling the same function reverse with str 1 colon minus 1 plus str 0 index. Right. Now let's see. Now I am going to do something like this. Here I am calling the function, but before that I have to assign some word str. I am assigning the word program. I am calling inside print, I am calling reverse, then inside that str is the parameter, like this. Now let's see. Now I am calling the function here str. So once I call it, it goes to here. Now what's the word inside str? Program. The word is program. Now this is program. Then we are counting the number of characters inside str by using the len function. So how many characters inside this? 1, 2, 3, 4, 5, 6, 7. Right. Now this is not less than or equal to 1 because we are getting 7 here. This output is 7. It's not less than or equal to 1. Because of that, if condition is false. Then we are coming for else. Right. This is the most important part you need to understand. str minus 1. So I will recall your memory, students. String is also just like a list. So the words are stored like this. P R O G R A M, like this. So there are two different indexes. Normal index is starting from 0. Normal index is starting from 0, 1, 2, 3, 4, 5, 6. And the reverse indexing minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7. Right. Now let's see. We are taking str minus 1. str minus 1 means this one, m. Right. So this is m. And again we are calling the function reverse with what? str, then this is starting with 1. Right? Starting with 1, you know that this is the starting position and this is ending position. Ending position minus 1 means minus 1 is not included. Up to minus 1. Then we can go only for minus 2. Here starting with 1, we can go up to minus 1 means we have to stop from where? We have to stop from minus 2. Right? Here, so what is that? Here, starting with 1. 1 means starting with R. Then we can go up to minus 1 means we have to stop from minus 2. ROGRA. Here, ROGRA. Plus, what is this? STR0. STR0 means P. Right? Now we have already called the first round. Then again we are calling here. Again we are calling, what's the value? Initially we called with program. Now we call with ROGRA. Here, ROGRA. Now here we have M and P. Right? ROGRA. Now len function returns what? 1, 2, 3, 4, 5. 5. It's not less than or equal to 1. It means this if condition is false. Now we are coming for else. Now ROGRA. Now what is this ROGRA? Here now ROGRA. It's also like this. Right? So indexes starting with 0, 1, 2, 3, 4. Here minus 1, minus 2, minus 3, minus 4, minus 5. Now str minus 1. Minus 1 means A. Now we are calling reverse. Starting from 1, we can continue up to minus 1. 1 means O. Continue up to minus 1 means we have to stop from this. OGR. OGR. Then STR0 means R. Again we are calling the same function with OGR. Now this is the third time. Right. OGR. right? OGR. So I will note that the reference for this OGR 0, 1, 2, minus 1, minus 2, minus 3. Now OGR, len function returns it's 3. 3 is not equal or less than 1. It means this is false. Again we are coming to this. str minus 1, it's R. Minus 1 means R. Plus we are calling the same function with starting from 1 up to minus 1. 1 means G. Up to minus 1 means there is no any other thing to go, only G. Right, only G. So we are calling the function again with G. That is our fourth round. Then here plus str0. str0 means O. Now we are coming with G here. Len function returns 1. Len function returns 1 means now it's equal to 1. Returning the same string, return str, same thing we are returning. So we are calling with G, returning also G. Here we are returning through this fourth line and we are coming to here. The answer for this one is G. Right? Then in this case, we are returning, we are inside else, we are returning RGO. RGO. In this line, we have created RGO. So we have to return RGO. So where we are returning, now line 4 is returned. Then the next return line is line 3. Line 3 means this one. Here, like this. This is the point we are returning. So now we know the answer for this part. It's RGO. Then what is the total statement? ARGOR. ARGOR. So we have to return. So we are returning through number 2. Here through number 2 up to this point. So we are getting to here. What is that? ARGOR. 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 So what is the total line? MARGORT. So now we have to return that one also. So we have to return from the very first call here. So we are returning to here. So what we are returning, we are getting here. So what is that? Let's see. Here. MARGORP. MARGOR, and finally we have P. Right? So in our output, what we are getting? MARGORP. So what is this? The initial word program. This is how we reversed it. The characters, the letters are reversed, right? Starting from here, you can see that PROGRAM for this side program. Now this side, it's reversed. MARGORP, right? So this is how we can use the recursion process for reversing letters. The reversing words. Right. Have you got that? Right. So one student is asking, sir, can we also make the condition as return str minus 1, then reverse 0 up to minus 1. 0 up to minus 1. Right, let's see. You are saying return str minus 1, the same thing, str minus 1 plus, you have changed this, 0 minus 1. 0 minus 1 means you have to start from 0, right? Let's see. Okay, now let's take the initial word, str minus 1. We are taking m, right here. We are taking m. Then just after that, start from 0 up to minus 1 means we are taking progra. We are taking only the m part. Right, okay. You can do that. Right? In that method also, oh, correct. You can do that one. Very good question. And your idea is also very good. The only thing, that method is correct. The only thing is, we have some much more remaining characters. When we compare with this method, in this method always we are removing 2 characters. And the rest of the thing is available inside the function. In next round, another 2, rest of the thing is available. But in your method, in each round, you are removing only 1 character. Then rest of the things inside the function. So you have to go more than this number of rounds. Rounds ගාන වැඩි. ඔය ක්‍රමෙත් හරියටම හරි. හැබැයි මේකට වැඩිය rounds ගානක් යන්න වෙනවා reverse process එකට ගන්න. Right? But your method is exactly correct. Have you got that? Is it clear for you? Right. Okay. Perfect. Right. Okay. My pleasure, student. And what about the others? I need your idea. Have you understood? Right. I'm asking from all of you. Right. Perfect. So what about the others? Right. Well done. Right. Okay. Right. Well done. Thanks for your response, students. Right. Okay, students, if you need, you can take screenshots what I have explained, right? Okay. Anyway, now we have explained that one also. Now, students, recursive versus iteration. We did 2 methods. Iteration means we have used for loops, while loops. And today we have learned recursion. Right? So these are 2 different methods. But we have to choose which one is right applicable, right, according to our requirement. We can't say iteration is best. We can't say recursion is best. We can't say like that. It depends on the situation. It depends on the background. According to the background, we can apply. Right? So all recursive solutions can be written as iterative solutions. What we are writing as recursion, the same thing we can write it as iteration. Recursive code often simpler than iterative. Recursive code is always simpler. Very few number of lines available. Thus easier to write, read and debug. Debug means if you are getting some error, very easy to remove errors because the number of lines are very less. Statements are very less. But recursive methods are often slower than iterative. Right? This process is something slower when we compare with iterations. Overhead loop repetition smaller than, right? Overhead for call and return, because overhead means something extra. When we compare with iterations, in recursive we have to do something extra. Because we have overhead, it means we have heavy weight, overhead for loop repetition. For loop repetition, smaller than overhead for call and return, right? when we are working with an iteration, we have a overhead, we have a weight of repetition, do the same thing again and again. But in this case, in recursion, we have to call, again call, then we have to return. Right? In iteration 1, we are doing the same thing again and again, that's all. But in this case, in recursion, we have to call until we are reaching the basic level, then we are return. So the weight is heavy when we compare with iterations, because we need to allocate some memory. In each round, we have to remember the status, right? We have to remember the status. Once you open the door, go to the room and keep the status, and open the door inside that room, then go to another room, keep the status. Why we need to keep the status? Because we need to return back. For keeping the status, we have to allocate some extra memory. That is the overhead, right? Once we are going for some destination, we know that in the first junction we turn to right, second junction we turn to left, again in third junction we go straight. Likewise, we have to remember. Why we need to remember? Once we are returning from that destination to where we start, we need to keep remember where we have turned in each junction. Other than that, we can't came back. We can't return. So likewise, in this case, recursion also we have to remember. To keep remember, we have to, right, give some extra memory. We have to allocate some extra memory for that. That is the overhead. When we compare with iteration, the overhead for recursion is higher than that, right? So what we have to do when we need it, right? In backgrounds, in some situations, we need that, we can use it. All the time, recursion is not good. For all the programs, if you are using recursion, you are not a good programmer, because you are allocating much more memory for recursion. But when it is needed, you can apply recursion. That is the best option. In any other situations, you can use iterations, just like for loops and while loops. Okay, right. Now students, you have some task. So you have to try this one in your tutorial session. Right. Towers of Hanoi. Towers of Hanoi. So I will explain you before stopping this lecture. I will explain you what is Tower of Hanoi. You can find this from Google also. But I will explain. What is this Towers of Hanoi? Towers of Hanoi means this is a game. Actually, we can solve this game by using a recursive program. We can use recursion to solve this game, right? Where in your childhood you did this program, I am pretty sure about that. Here there are 3 poles like this, right? So in this 3 pole, one pole is having, this is the starting position of the game, right? Here 3 discs, one large disc and middle disc and small disc. This is the basic version of Towers of Hanoi, right? Then what is the challenge in this game? You have to move these 3 discs into a different pole, but there are some rules, right? You can't put, right, a larger disc on top of a small disc. This is not allowed. Always you can put a small disc on top of a large disc. This is allowed, right? You can't do this, right? This is allowed. Right. Now I am going to explain how to do this program, because I just want to give you this idea. But you have to think how to do this by using recursion. That is your part. But first of all, I have to introduce this game for you. How to solve this game. Right. Now in next level, I am drawing this very basically. Right here. These are the 3 balls. So I am taking this one, right, the very small one, into other ball like this, and other 2 large discs are available here. Right. In the next step, I am going to do, right, now what's the next thing? Then here, now this is here. Now we can move this disc into a different ball. Here I can't put this one into here because it's not allowed, because this is larger than this. So I'll move like this. Now this is smaller, this is the next bigger one. Right. Then the next level, what I am going to do here. Now I can move this one to here. Medium one, on top of that I can put the small one. Now still the larger one is here. Right. Then what we can do in the next level, now I can move the larger one from here to here. This is the larger one, and still the middle one and the smallest one here. Right. Now in the next level, here the larger one is here, and I'll move the small one to here like this. Now the middle one is still here. In the next level, what we can do, now the larger one is here. Now you can move the medium one to on top of that, and still the small one is here. And in the next level, we can completely solve this. Larger one and the medium one is here. The small one you can shift it to here. Now you won the game. Now you win. Right? Now what is the challenge? Initially it's in a different ball. What is the challenge? You have to move the discs into a different ball. Now you already moved. Right? So this is the game. Right? Right? Most of you have played this game, right, in your childhood. Right? Now you know how to play this game. If you don't know, now you know. Right? So now what you have to do is, now you have a challenge. Now you know how to play this game. Now try to apply this solution for this game by using recursion in Python. Right? Take your challenge, and you can get the support from Google if you want, but better to try by you first. Better try by yourself first. If you are unable to find some guidance by yourself, then you can access Google and get some support. But don't copy the program which is in the Google into your notepad and don't show to the right instructor. Okay? Don't do that, because I just want to improve your thinking. Right? Try to do it by yourself. That is how you can improve your brain. Right? Okay. Right. Should we assign numbers to the disks for that? Yes, you can assign numbers, because in this case, students, the only method, because we are giving a solution by using a program. So you can assign numbers, right? Very good solution, right? Okay, and students, is there any question? Are there any questions? Do you have any questions? Because today's content is finished, then you can go ahead with your tutorial, right? And students, our instructor told me that, Mr. Udara told me that your participation is not good for the tutorial, right? So from my side, I'm kindly requesting you, please participate for the tutorial. It's very important, right? So today is the last session we are doing as online. From next week, starting from next week onwards, we are doing physical. So we have one more remaining lecture. I'm planning to do it in physical, and also we are continuing the rest of the time with tutorial sessions, right? Please, today also, please participate for the tutorial session. It's very important. And next week onwards also, you have to participate physically for lecture and tutorial sessions. Right, one student is asking, sir, can you show the note you written again for small time? Sure, no matter. Right. Okay, which note you needed? The last one. It means this Tower of Hanoi or a different one. This one, no, different. Which section you have missed? All right, okay, last one. Okay, take this note. Right, okay. Okay, it's my pleasure. Right, students, now we can wind up the session, right? Please continue with the tutorial. It's really important for you, right? Okay, right. Finally, I'm asking the question, what about today's content? Is it clear for you, students? Please respond to me. I just want to know about your current status. What about today's content? Is it clear? Right, perfect, right. Okay, thank you so much for your response. What about the others? I am waiting for others' feedback also. Right, okay. Thanks for your feedback. What about the others? Right. Please send me your feedback about today's content. Right. Any others? What about your idea? I'm asking about the today's content. Are you clear? I just want to get some idea about today's content. That's why I'm asking. Others? Right, okay. Okay, right, perfect. Okay, students, thank you so much for your response. Right, so I'll inform instructor Mr. Udara to start the session just after 10 minutes, okay? Okay, please participate for that session. It's really important. Okay, students, for all of you, I'm really thankful for participating for today's lecture. Okay, right, we'll meet on next week. Okay, bye. Okay.